Yaskawa.
Good morning, everyone. This is Jamie Solt. I'm a product engineer in the motion control group, and I'll be conducting the webinar this morning on commissioning a system with M3Servopacks. For our agenda today, we're going to do a Mechatrol 3 overview first, then we're going to talk about node discovery, some errors into the discovery process, saved configurations, and then I'm going to give you a list of recommendations. So here's a slide directly from the Mechatrol Members Association comparing Mechatrol 3 to Mechatrol 2. As you can see, Mechatrol 3 has a higher baud rate. It has lower cycle times. As I said, these cycle times are for the Mechatrol 3 specification. For our controllers, we realize cycle times in the range of 250 microseconds to 4 milliseconds. And there's a special option where we can go 125 microseconds with specialized drive firmware. The string size is also increased in Mechatrol 3, although the controllers are restricted to 48 bytes only. We've increased the number of stations to 62, and also the maximum transmission distance, instead of 50 meters for the entire network, is now 100 meters between stations. One of the drawbacks in increasing this size is that now all the Servopack nodes are active nodes. They're no longer static. What that means is if the node is not powered, you lose everything downstream from that device. Under Mechatrol 2, it didn't matter if the node was powered or not. You could still see all the nodes as long as the cables were plugged in. But with Mechatrol 3, the device must be powered to see downstream devices. They've also eliminated the minimum distance between stations, and we now offer a 0.1 meter cable. For topology, Mechatrol 2 used to be pretty much straight line, and now you have some options there. There's more on that later. For communications, it includes both cyclic and event-driven communications in the Mechatrol 3 standard, although for the controllers, we still only implement cyclical communication. Transmission cable, it's now similar to Ethernet cable that we support. There's also two other features: slave monitoring slave, which means one slave can see another slave's data, and hot swapping, which means you could actually plug a device in and have it be recognized. But again, those things are supported by Mechatrol 3, but unfortunately not supported by our IEC controller. A little bit more about the topology. As I said, you can do cascade, which is straight in line. You can also do star with the use of an M3 hub. And you can also mix the two, a combination of cascade and star. That really gives you flexibility in configuring your system. There's a new feature under Mechatrol called extended address, so that you can have 4 nodes and have 5 servos and 1 I/O device seen from the master. The way that works is the first node is set at address 3, but behind the scenes, Mechatrol 3 superimposes or pre-pens a number to that node address so that it can actually talk to multiple servos at one node. This feature is going to be used in the upcoming Sigma 7 series, where we have an amplifier that has 2 motors, an amplifier that can run 2 motors. So it'll be using this feature of extended addressing. The only thing you have to make sure of is that if you have an address set for this multiple address device, the next address has to be 2 higher than the first address, because internally, if we have an address set at 3 for this node, we're really consuming nodes 3 and 4 in the controller. Here's a little slide that shows the transmission cycle. And you can see in the transmission cycle that you set on Mechatrol Link, there's a sync frame where everything gets synchronized, and then there's cyclical communication between all of the nodes where we do a command response. Mechatrol Link 3 also allows for retries, so it makes it very robust because you can have up to 4 retries. So if one of the devices fails, right in line with the frame, we can send a retry and not disrupt that communication. In Mechatrol Link 3, the cabling is very robust, much more robust than under EtherCAT or standard Ethernet protocol. Typical devices use PC parts for the Ethernet connection, where we use a industrial connector that's fully shielded, and also the cable itself is fully shielded. And you can see in contact points, most cables only have 1 point, where the Mechatrol Link 3 connector allows for 2 points of contact. What this does is make the system very reliable, resistant to noise, vibration, and also of the connectors pulling out. So as far as node discovery, what has to be set up for the controller to find devices? First, you have to have correct settings on the amplifiers and controller. All the devices have to have unique addresses, and the devices must be powered up before the controller is powered up. And so in terms of settings, on the Servopack, you have switches that need to be set, for the transmission size. The controllers are all configured to use 48 bytes, and the switch's default settings are 48 bytes. So you just need to check that they are in the default position, and then adjust the address at switch 1 and switch 2 so that all your addresses are unique. There's a couple of LEDs that are available on the Servopacks, L1 and L2, and that just indicates that you're connected to an active node. So if you have a cable plugged into your Servopack that's also plugged into another device that's active, these LEDs will be lit. It's very useful to make sure your cabling is in the correct position. And on the controller, you just need to have the config switch on and then power up the amplifiers before the controller. So with everything connected up, all addresses unique, amplifiers power before the controller, we see that when we look with hardware configuration, we can see all of the axes, and if we connect, everything's available and online. This is what I call the happy case. Now, what happens when something goes wrong? Well, if you have an incorrect number of bytes, if you power up the system, you'll see an alarm light on the controller. You look at the web server, and it'll show a Mechatrol Link node initialization error. If I reboot a second time with that, I'll still have the node error, but I'll also have an additional error. So it'll bounce between these two states of just showing the node error or showing the node error plus some problems with an individual Servopack. Of course, the remedy is to correct the number of bytes. If there's duplicate addresses on the system, you'll get the network communication device failed to initialize. If you have a saved config on there, you'll also get that same alarm, but it'll also flag which nodes you were not able to communicate with that were configured. And then there's also the possibility of addresses out of range. So for all Mechatrol Link 3 controllers, MPiec controllers, the allowable address range is from 3 to 64. Doesn't matter how many devices your controller is configured to support, it'll still accept addresses in this range. Doesn't matter if you're only configured to allow 8 or if you can have 62. So what happens if you set the access number too low? That'll actually show up as an amplifier alarm, an AE42. And that's a Mechatrol Link station address setting error. So if you see that, you know right away your address is out of range and it's too low. If your access number is too high, Mechatrol Link 3 does allow you all the way up to 239. in terms of your address range, but again, we only support addresses up to 64. So for addresses from 65 to 239, the access will simply be ignored. You won't see it, you won't know it's there. But you will be able to find every other device on the network. So what happens when the controller can't find devices? What causes the error? How do you know the error has occurred? And what do you do to correct it without losing your settings? One of the things we know that causes the error is configured response times. So here I have an example of a good 16-axis configuration. And I went in and I set all my response times to the lowest value. I saved this to the controller and I cycled power on my system. Try to connect with HC and all my axes show up as offline. If I look at the web server, I'll see that all those axes are flagged with an error, and I'll see a MPiec node initialization error. If I simply reboot the system at this point, I'll get a different alarm, or a different set of alarms, that show the servo network communication device failed to initialize. At this point, just power cycling the controller or rebooting it will bounce me between these two states forever. So you might think attempting to set a response time that's really high would be a way to get out of this. And I tried that, and I found I received the same two errors. So it doesn't matter if the response time is too high or too low, you'll see the controller bouncing between these two sets of errors. So what are some of the solutions? When you see the controller toggling between these two alarms, the servo network communication device failed to initialize and MPiec node initialization error, the Servopacks must be power cycled. They won't show any alarm, they won't give you any indication there's anything wrong, but you'll never be able to connect with the controller until those Servopacks are power cycled. If you have a saved configuration, then the configuration most likely has a response time that's set either too high or too low. So what can you do to correct this? First, try power cycling the entire system. That's always the easiest option. If that gets you out of it, good. If that doesn't, then you either have to delete all the config files and rediscover the entire system, or download a new configuration with more accurate response times configured. So if you go into the HC, one of the things we have here is called default response time, and it's set at 62.5 microseconds. Most of the time, simply clicking on this link to set all your nodes to the default response time and then sending that configuration to the controller will work. And you do that by saving the configuration and then going into the online controller configuration utilities, and then use the top radio button to send the offline config to the controller and reboot it. If that doesn't work and you want to get into a more detailed configuration, there's a MPiec 3 utility, and that's available from the MPiec members website. It's only available to members, but the membership is free, so you just need to sign on to get this tool. And this tool lets you diagram your system. You can see here I've diagrammed a 16-axis linear system. And then you hit this calc button, and it shows you all of your default response times. So this area over here is a picture from HC, where I've actually shown my measured response times that get copied over to configured for the same system. And you can see my numbers that were actually measured range from 20 to 48 microseconds. And in the utility, it shows these numbers from 18 to 47. So it's very close to what the actual system would be. And this would be one thing you could use to change your response times to the correct one. When I sent out questions for this webinar, somebody responded back with this statement. They said that if the 3200 was powered up before the drives, all the drives show up as offline in hardware config. Then they found they could reboot, or Then they found the controller runs without any issues after resetting Mechatrolink and clearing the alarms, but the drives still show up as offline in the hardware config. So how do I get the drives to show up as online in hardware config? If the axes are not powered, before you power up that controller, they'll never show up online. You can see we look at the auto-discovered configuration, and with either no save config or a saved config in the controller itself does not see any axes. So if I select the saved config and go online, the axes show up as offline. Even if I go into hardware configuration, do a reset Mechatrolink, and reconnect to the device, the axes still show up as offline. What you need to do is power cycle the controller after the servo packs have been powered up, or reboot the controller after the servo packs have been powered up, and then reconnect. And then your axes will show up online. So there's this concept of a disco configuration, and that's found in the web browser. For your axes to show up online in hardware configuration, they have to appear in this disco folder, or they have to be found by the controller. So you can see in my first case, with no startup, you have to have your config switch on before you can find any axes. And with a startup, it doesn't matter if config is on or off, you'll still find the axes. However, when the axes are not powered, it doesn't matter if you have a startup or it doesn't matter what you do with the config switch, you will never see these axes. So the bottom line is the axes should be powered before the controller. So just to recap, when the controller can't find devices, what causes the error? Well, it's either your configured response time is either too high or too low, you have duplicate addresses, the data size is set incorrectly, or the controller was powered before the drives. How do you know this error has occurred? You'll see one of these following two errors on each reboot, which is the servo network communication device failed to initialize, or Mechatrolink node initialization error. And what do you do to correct it without losing your settings? Well, the first is to check all your switch settings, check your cabling, and then try and power cycle the entire system. Again, if that doesn't work, then you either have to delete all the config files and rediscover the system, or download the new config with accurate response times. If you're really not sure what to set the response time, you can always open a new project, power cycle the whole system, and just let the controller find the devices, go online from your new project, and you can record what measured response times the controller sees. So in closing, the recommendations: always power up the drives before the controller, or you can power up the system all at the same time, because the amplifiers power up much faster than the controller. The controller takes a few seconds to power up. When you're designing your system, especially if you're reproducing this, you should include a cabling drawing or a list so that you identify where each Mechatrolink 3 cable goes, because order is important. If you change the order of your cabling, that's going to change the value of your response times, possibly making it that you won't be able to find devices. When changing the cabling, don't forget to update the configuration. Also, if the axes are not in disco, and not in the hardware.xml file in the discovery folder, the HC will never display them as online. To see axes in hardware configuration, they must be powered on when the controller is booted up. And this is regardless of the position of the config switch. So that's all I have for the webinar. Does anybody have any questions?
There was one question about the timing of the power on sequence between the MPiec controller and the servo packs, but I think you had answered that question in your discussion just here about the controller taking more seconds to power up than the servo packs?
Yes, that's in general. In general, I've found it's okay to power up the entire system at once because the amplifiers always come up before the controller. But if you want to make certain, you should power up the amps first.
Sure, this may be the case where there's more confusion potentially in a commissioning situation, especially if the controller is on a separate power supply, a 24-volt power supply, and the servo packs are being powered separately. There may be some additional timing consideration during commissioning where this may be important to remember. Jamie, can you explain a little bit more about the Mechatronic 3 topology options using the hub?
Well, the hub has 9 ports on it. So you can connect the hub to the master, and you can have 8 additional lines going out of there. And the hub reduces your time drastically. You can see in my example, when I had 16 axes in a straight line, I got ranges from 20 to 47 microseconds for my response time. Whereas if I had those same 8 axes and they were on one hub, I would expect to see response times all in the 20 microsecond range for the entire network. So the hub really is there to decrease response time or increase throughput.
And I think using a hub also offers the benefit of the ability to make modular machines where certain servo pack devices don't necessarily need to be present all the time for the system to remain operational.
And also the hub allows you to disconnect devices without losing more of them. When you have a linear topology, as I said, because of the active nodes, when you unplug one device, everything downstream is gone. With the hub, in the 8-axis system, I can unplug any one of those devices off of the hub and still have the 7 remaining.
Okay. Thank you very much.
Okay, everybody have a good day. Goodbye.